I'm going to walk through this example with calculating these delta using different kinds of contracts and also using the spot. This is the silver example that's given. I have this in the slides. It's easier to use these functions here that are given to calculate delta. So I'm just going to do it that way. You can do it the long way if you want to. But this is more just about what happens when we change what we're hedging with and kind of some of the relationships there. So I'm just trying to show you this, and I'll show you this in the spreadsheet here. So the initial question is, what is the delta of a short position in 1,000 European call options on silver futures? Now notice these are options on futures. Okay, so if we're going to use our DerivaGem formulas here to calculate this, we have to remember that it's futures. So put in here, we've got the is future, we've got that true. So we've got an option on the futures contract. All right, and I put the inputs in here. It's the current futures price is 8, the exercise price is 8, we've got 12% risk-free. I've got a dividend yield in there, but I don't need it. It doesn't change anything. I'll just go ahead and put that 0 so it doesn't throw you off. It's not used in this calculation since it's futures. The volatility is given at 18%. Now notice that's the volatility of the silver futures prices, 18%. That's the volatility of the futures price, right? The time to maturity there is given. The option on the futures is 8 months, so that's 8 out of 12. It's a call option and it's a future, so I've got those in there. I'm looking for delta, so my result is 1. And that gives me an answer here of delta 0.4886. Right? And then it asks you some other questions. First, I want to be sure that you understand what this 0.4886 tells us. The question here is, what is the initial position in 9-month silver futures necessary for hedging? So we have a call option on silver futures, and we're going to hedge with futures contracts. And so what that delta tells us here, right, that 0.4866 that we calculated, it gives us the change in the price of the option on the future relative to a change in the futures price of the asset. Right, so delta's given us this ratio right here. And that's important to kind of understand the ratios we're dealing with here, because when they ask you the other questions, you've got to know what these are to figure out how to put these together, right? So again, that first option is the change in the price of the options on the future given a change in the price of the futures, or the futures price. Okay. All right. And then the next question says, well, suppose you were going to hedge with silver. Right, so you've got a call option on the futures, but you're going to hedge it by buying a certain amount of silver. Right? And so say, okay, well, now what we need is we need to know how the price of the option on the futures will change relative to a change in the spot price of silver. Okay, not relative to the change in the futures price of the asset, relative to a change in the actual price of silver. And so you go up here and you look around and say, well, what information did you give me about the prices? Well, they don't. Right? They don't give you any information about the price of silver. So you have to infer that from what you're given from the futures contracts. All right? And that's the key piece of information here, is that you know that the delta of a futures contract, right? The delta of a futures contract, there's some derivation of this in the slides. We talked about this in the previous chapter. You can do the derivation here and figure this out. But the delta on a futures contract is just e to the RT, which is a nice property. And notice what that's telling you. That's telling you the change in the futures price of the asset relative to a change in the spot price of the asset. All right, so here's where we get our spot price in. So that we know that the delta on the futures contract, right, not the delta of the option on the futures contract, just the plain old delta of the futures contract, is e to the RT, and that's relative to the spot price, change in the spot price. All right, so I've done the calculation there to get e to the RT, and now I'm saying, oh, okay, well, I know from using my DerivaGem formulas, and you can calculate this a long way if you wanted to, I'm given delta that gives me the change in the option on the future relative to the futures price. I also know the change in the futures price relative to the spot price. Okay, and then what the question is asking me is, okay, well, what is the change in the price of the option relative to the spot price? Price of the option on the future relative to the spot price. So I can just put those two together and multiply them together, and I've got these, the change in the futures price of the asset both in red because they'll cancel out. Right? If you multiply these two together, then they'll cancel out, and you'll be left with the change in the futures price on the option relative to the change in the spot price of the asset, and that's what you want. Okay, now that's an awful lot to go through just to say you multiply those two together, and yeah, you can look at the answer and see, oh, I just multiply those two together, but I'm trying to show you why that works. Okay, and it works because the ratios will cancel out, and you're left with that relationship's there. The change in the price of the option on the futures relative to the change in the spot price of the asset. All right, so that's the answer to part B. And then we do the same thing here with the next part. It says, well, suppose you were going to hedge with 1 year silver futures, right? So you've got an option on 9-month silver futures. You're going to hedge that by taking a position in 12-month futures. Why you would ever do that, I don't know. I don't know, perhaps there aren't enough 9-month futures available, and so you're going to use 12. I don't know, but it's an interesting intellectual exercise anyway. All right, so we've got an option on the 9-month futures. We know that delta. All right, so again, it's a change in price of 9-month futures, the option on 9-month futures relative to the 9-month futures price. We can calculate the delta of the 12-month futures, right? And that's just here. The 12-month futures price relative to the spot price is just it's e to the RT. Okay? We know the delta of the futures contract. All right. What we want to know is, how does the price of the option on the 9-month future change relative to the price of the 12-month future? Okay. And so say, okay, well, what I know about the 12-month future is relative to the spot price of the asset, right? But I also know the delta of that option on the futures relative to the spot price of the asset. That's my answer from the previous problem, all right? That's the stuff I just went through here to get the previous problem, all right? And so what I need to know is this, 9-month futures relative to 12-month. What I know is the 9-month relative to the change in the spot price. I also know the 12-month futures relative to the change in the spot price. And I hope you can see that if you take this equation and this ratio and divide it by this ratio, okay, remember when I divide, I'm multiplying times the reciprocal. So if I take the reciprocal of this, I'll have the spot price on top and the 12-month futures on the bottom, and then the spot price will cancel out if I multiply it times this. Right, and in fact, I guess I can just, if I take this formula here, and then I'm going to multiply it times the reciprocal of that other formula up there, which is my delta on a 12-month futures contract, and so this is the change change in the spot price relative to the change in the 12-month futures price. Okay, and if I multiply those two together, take that out because I'm just trying to show here. Okay, if I multiply those two together, notice the change in the spot price will cancel. And what I have is the change in the price of the option on 9-month futures relative to the change in the 12-month futures price, which is what I want. Since I'm trying to hedge my 9-month option on futures by using 12-month futures contracts. Okay, so to get that, again, this is an awful lot of setup just to say take that number and divide it by the other one, but I'm just trying to show you where that comes from. So I took my answer from point B, which is this, and then I divided it by the delta on the 12-month futures price, which is multiplying it times this. The spot price is canceled, and I'm left with the relationship that I want, which is the changing the option, the 9 months futures relative to the 12-month futures price. All right, I get that number there. By the way, if you're looking at the solution in the textbook, this really threw me off for a while, and I couldn't understand. I just couldn't understand what they were doing here. Remember that. I was going to write the formula here, but maybe I'll just mention it here. Remember that if you divide by e to the RT, that is the same as multiplying times e to the minus RT. Alright? Because in the textbook solution, they just say, well, multiply it times e to the minus RT, and it took me a long time to say, oh man, don't they have that? Shouldn't they be dividing? They are dividing. They just changed the sign on the exponent. Okay, so there's that one. As I say, it's a lot of setup there. The actual math is pretty easy. You just take two numbers, multiply them together, and divide them. But that's why you're doing what you're doing. So there's that one.